In this class, we prove an important relation relating to forward difference operator, and the relation is so that delta to the power m 1 by x, this is the mth order forward difference of 1 by x, which is given by minus 1 to the power m into m factorial into h to the power m by x into x plus h into x plus 2h to x plus mh, where h obviously being the step length. Okay, now we start from the first order forward difference delta 1 by x, and using the definition of delta, we know that the definition is delta f of x, this is equal to f of x plus h minus f of x, since h is the step length. So we write the definition here, this is 1 by x plus h minus 1 by x. Now taking LCM, we get this is x into x plus h, and this is x minus h. So we get this is minus 1 to the power 1 into 1 factorial into h to the power 1 by x into x plus h. Okay, so the given relation is true for m, this is equal to 1. Okay, now taking second order forward difference of 1 by x, and this is given by delta minus 1 to the power 1 into 1 factorial into h to the power 1 by x into x plus h, because delta of delta 1 by x and delta 1 by x is equal to this. We already find this data. And using the definition here, we get taking common minus 1 to the power 1 into 1 factorial into h to the power 1, and now use the definition of delta as x plus h into x plus 2h minus 1 by x into x plus h. In the first term, we put x plus h in place of x, and in the second term, this is remains the same as above. Now again we make LCM, we get x into x plus h into x plus 2h. Then this is minus 1 to the power 1 factorial h to the power 1, and this is given by x minus, this is x minus 2h, and clearly this result gives x cancel out, another one minus out of the bracket, then minus 1 to the power 2, and this is 1 factorial into 2, this is 2 factorial, and this is h and h also, this is h square by x into x plus h into x plus 2h. So this is true for m, this is equal to 2. Okay, now we let it is true for m equal to r. Then the result gives delta to the power r 1 by x. This is given by, we put the value in the right side by putting r in place of m. So this is minus 1 to the power r factorial h to the power r by x into x plus h, x plus 2h to x plus rh. Right, now we take delta in both sides against, then we get delta to the power r plus 1 into 1 by x, and this is delta minus 1 to the power r factorial h to the power r, this is x plus h to x plus rh, and again we use here the definition of delta. We first take common this term factorial r h to the power r, and use the definition of delta here. This is x becomes x plus h, x plus h becomes x plus 2h, and similarly this is x plus r plus 1 into h. Okay, this is the first term, and the second term remains this. This is x plus h to x plus h. Okay, now making LCM of these two terms, we get minus 1 to the power r factorial h to the power r, and this is LCM is x plus h to x plus r plus 1 into h. Okay, and the numerator is, from here we get this is x, and from here we get x plus r plus 1 into h. Okay, and opening the bracket, this is minus and this is also minus, so x cancel out, so we get from here 1 minus extra and 1 r plus 1 extra. Then we get the result as minus 1 to the power r plus 1. This is r factorial and this is r plus 1, so this is r plus 1 factorial, and this is h to the power r, and again 1 times h, so h to the power r plus 1 by this is x plus h to x plus r plus 1 into h. Right? And clearly we say that the relation is true for m equal to r plus 1 if it is true for m equal to r. So by using principle of mathematical induction, we say that this relation is true for all m belongs to the natural number. Okay, that is true for every value of natural number. This is the first law of induction. Right? So we prove this result very easily by using first law of mathematical induction. Thank you for watching.